Talking about specific environments now. So the first one is responses to acute heat stress. All right, so with each of the videos over the next, the rest of the semester, we're going to go through heat, we're going to go through cold, we're going to go through altitude. And for each of those, there's going to be two videos, one about acute stress and one about chronic stress. So one's what happens when we go exercise in the heat, and one's about what happens after we exercise repeatedly in the heat. So here are the objectives for this lecture. So we're going to talk about just the physiological challenges, what happens, and then we're going to talk about cardiovascular drift. Okay. Now, there's a little bit going on in this picture here, but basically what happens is as we exercise in the heat, that's going to cause a couple of things. And so it's going to change our ventilatory pattern, it's going to increase our brain temperature, and we're also going to have decreased blood flow to our intestines. Okay. Ultimately, what we're going to focus on, though, is that force production is going to be decreased and we're going to experience fatigue. So there are two primary demands that occur when we exercise in the heat. And the first one is we have to get oxygen to the working muscle. This is always the case regardless of what environment we're exercising in. We have to get oxygen to the working muscle. The second challenge, which is in essentially direct opposition of the first one, is that we have to increase skin blood flow because that's a way that we dissipate heat, right? We talked about this at the end of the last lecture, is that when it's hot, we increase skin blood flow so we can dissipate heat. So by doing this, this reduces the amount of blood that goes to the active muscle, which means there's less blood returning back to our heart, so our stroke volume decreases. Now, we can increase our heart rate to try and compensate for this. This is generally accepted that this is the mechanism. We have low stroke volume, so it causes increased heart rate. However, it's also possible that the heat, which speeds up chemical reactions, is causing an increased heart rate. My thought on the matter is that it's probably a little bit of both, but I think primarily it's due to this decreased stroke volume because we're sending extra blood to the skin. All right, and so as a result, we're going to have a cardiac output that's higher than normal in the heat compared to just regular temperatures because we have to send extra blood to the skin to try and dissipate heat. Consequently, VO2 max occurs at a lower intensity and the value itself will be lower because we're sending blood to the skin not to deliver oxygen, but to get rid of heat. Okay, so just to kind of tie this together, no matter the activity that we're doing, there is a certain cost, oxygen cost associated with it. All right, and so once we get steady state, our VO2 will be constant. And we can measure this, or we can show that this is going on in the lab by having VO2 being constant and heart rate being constant. However, heat prevents or makes it more difficult for heart rate to reach a constant value or a steady state value. And this causes something called cardiovascular drift. And so this figure is right out of your book. So notice that we've got time on the x-axis, and then we've got percent change basically on the y-axis, and this is the percent change after 10 minutes. This is steady state exercise, so just think that the people who were doing this were exercising at 200 watts for an hour. Okay, and so what they did is they took measures of heart rate, cardiac output, blood volume, pressure, and stroke volume, and then based on the changes, that's where these graphs come from. So as you look here, there's things that change, right? So when we have this long duration steady state exercise, notice that heart rate goes up. And so we see that, I'm trying to find my little cursor. So this is heart rate right here. Okay. But stroke volume down here goes down. However, at the same time, cardiac output, the blue line, remains relatively constant. Notice also that pressure decreases as time goes on. Now the question is, why is heart rate going up when stroke volume's going down? And so there's two theories, and it ties back into what I said a little while ago. Okay, so we send more blood to our skin. That causes less blood to return back to our heart. And so we're going to have less blood to eject, which means stroke volume is decreased. Okay, and so we can compensate for that by increasing heart rate. So if I decrease stroke volume, I increase heart rate, and then I can still maintain cardiac output. The other theory is that due to the heat, heart rate increases because heat speeds up chemical reactions. So my heart rate will increase, which leads to a decreased filling time, which decreases stroke volume. Okay. And like I said before, I tend to believe that it's this one. I think there's more evidence to suggest this one, but I also believe it's not simply one or the other. I think it's a combination of both. But that this first one is the bigger driver. Okay. So I know some of you are probably thinking, well, we talked about that exercise increases heart rate, but stroke volume continues to increase. And that's absolutely true, right? We've talked about the pumps and torsion and things like that, but temperature could potentially increase heart rate, or does increase, or could increase heart rate above normal, such that the pumps and torsion aren't enough to compensate for that. And so stroke volume would actually decrease. And so we're going to end there. We'll talk about it more in class and get into this and hopefully have a good discussion.